Okay, this is day 4 of the 8th grade math packet, the second packet. All right, so we have a task, and we have 2 people that are saving money and also earning an allowance each week. Okay, so we want to compare their earnings and complete the tables and then write equations and then graph the 2 equations. So again, this is a system of equations problem. We do have a graph, and we're going to see how their graphs look. All right, so looking at these tables, we should have one for each person. It looks like there's a mistake. So the second one should say Jordan's weekly total, and that's going to be a J. Okay, so it looks okay now. Okay, so complete the 2 tables shown. So we need some information about the money they're making. So let's look at Kimmy's earnings. So it says she earns $9 an hour at her job, and her allowance is $8 per week. Okay, and then Jordan earns $7.50 an hour, and his allowance is $16 per week. So we're actually going to need to know how long to compare. So is this more than 1 week? The table goes up to 7 hours, okay, not 7 days. But if we look at part B here, or question B, the end of 1 week. Okay, so the end of 1 week. So let's focus on that. Okay, so let's just consider that 1 week. So we have, so for Kim, if she works 0 hours, then how much money does she have? So think about the whole week. So she's already going to get her $8 allowance. So for sure she will have $8 if she doesn't work at all. And then if she works 1 hour, she has $9 for that 1 hour for her job, and then the $8 that she gets no matter what. So it's always going to be 8 plus whatever she makes at her job. So $9 plus 8 is 17. And then if she works 2 hours, she gets 2 times 9, which is 18, plus 8 is 26. Okay, so instead of, we have a pattern here, right? We know it's going to be a straight line, so the pattern is going to be consistent. The slope is going to be consistent. So what is that slope? It is her hourly rate, $9 per hour. So we're adding $9 each time. So that should help us to fill in the table a little bit faster. So from 26, we go to 35, and then 44, and then 53, and then 62, and then 71. Okay, moving on to Jordan's. We have, just gonna write this a little bit easier to see. Jordan's a weekly total savings. Okay, so for 0 hours, if he does not work at all, he will get $16 for his allowance. So he starts off with more money. All right, and then if he works 1 hour, so at $7.50 for that hour, then he's going to work $7.50, or 7.5 plus 16. So that gives him $23.50. Okay, so 2 hours at $7.50 is 15 plus 16 is 31. Okay, and again, we should realize that we're just adding $7.50 each time. Okay, so again, you can use a calculator. So 31 plus 750 is 38.50. 38.50 plus 750, 46 plus 750 is 53.50 plus 750 is 61, and then 68.50. Okay, so we have our tables finished. So just take a look at these tables. even though Jordan starts off at double the amount of money that Kimmy has, look how it adds throughout each day. So at day 6, he has $1 less than Kimmy. So that's interesting. Even though he started off with $8 more, by the 6th day, or the 6th hour of working, he has less money. And that's because he's making much less per hour. All right. So next is writing equations. So Kimmy's, again, we're going to need, I'm just going to write it up here. So y equals mx plus b. So in this case, the m would be the dollars per hour, right? That's how much they're making at their job. And then b would be the allowance, because that's not changing. They'll always get that. All right, so let's do Kim. So K, so instead of Y, I'm going to put a K. So that's for Kimmy. So K equals M. What's her slope? Is 9. And then H, so this is X and this is Y. So we're going to put an H, so times the number of hours, plus $8. Okay, and then we have Jordan's. He makes 750 times hours plus 16. All right. Part C. Oh, well, let's just bring that right there. Okay. So that was Jordan's. And then D, sketch the 2 graphs. And then we need to figure out who will save the most amount of money in a week if they both work the same number of hours. Well, kind of like our previous day, the cell phone problem, it depends how many hours. So the same number of hours. So we'll see this on the graph. So let's graph it. I'm actually going to use Desmos again to graph this. So we have K equals 9H plus 8. K equals 9H plus 8. Okay, delete those that we used before. So I'm going to use Y and X. So Y equals, what was it? 9H plus 8, or 9X plus 8. 9X plus 8. Okay, so that's Kim's. And then Jordan's is in green, and that's 7.5x plus 16. 7.5x plus 16. This is in green. All right. So we were using this from a previous problem. So I'm going to change this. So the x-axis is the number of hours, right? Number of hours. Okay, and this is this is for each week now. So weekly savings. Okay, and then let's think about our numbers. So this would be like if we did a paper graph. So what kind of numbers would we need here? So let's go back to our table. So for the y values, we need maybe just 0 up to 100 for the y. I mean, if we go to 71, we go to 68, so 0 to 100 should be good for the y. And the x from maybe 0 to 10. So from x, let's change that to 0. Let's change that to 10, so it's easier to see everything. And this is why we want to choose good numbers, so that we can see the graphs a little bit easier. Y from 0 to 100, we said. And then, yeah, we can definitely see our 2 lines a lot better now. And then it's basically asking who will have more money, but again, it depends on how many hours. So let's take this graph and bring it into our packet. Okay. So here's this. Where'd it go? Okay, I'm going to put it right here instead. Okay, so this is our graph. So let's make some sense of this. All right, so if they work just 2 hours, okay? If they work just 2 hours each week, then who will have more money? Okay, here's their two graphs. So the one that comes out at the highest is the green, and the green is for Jordan. Okay, so the green is Jordan, so this is Jordan, and then the purple is Kimmy. Okay, so they work just 2 hours each week, then Jordan will make more money. He'll make about $30. Okay, if they work 8 hours each week, then who makes more money? Okay, the one that's a little bit higher, and that's Kimmy. She'll make about $80. So it depends on how many hours they work. So for part E, it just says, Jordan wonders who will save more money in a week if they both work the same number of hours. Write an answer for him. Okay, so it really depends. And if we click on this in Desmos, we have this point right here. That's the point where they cross. So at this very point, they are exactly the same. So if they work 5 1/3 hour, they will both get $56. So if it's less than that, then Jordan will make more. If it's more than that, if they work more than that, then Kimmy will make more money. And that's how we can answer this. We don't have to use the 5. So let's just say, let's make it easier numbers. So 5 hours or less. Okay, so 5 hours or less. So if they work maybe just 0 to 5 hours, then Jordan will make more. If they, let me just move that up a bit. Okay, so if they work, let's just say 6 or more, 6+ hours, 6 or more hours, then, okay, 6, if they work 6 or more hours, then the purple line will be up higher, so Kimmy will make more money. Then Kimmy will make more. Make more. All right, so it just depends. It depends on how many hours they work. And that's the thing about systems of equations. We have multiple answers depending on where we're looking. Okay, so let's move on. More practice with graphing and looking for solutions, which is a solution for a system of equations is that point where they cross. So when are those two numbers equal? So thinking about our number problem here, our allowance, our savings. So this answer would be at 5 1/3 hours of working, each person would make $56. Okay, so that's what we're looking for. But this time we don't have any context. It's just X's and Y's. So I'm going to do one. Let's do one that, everybody wants me to do the fractions because, for some reason they seem difficult. So let's do this. So I'm going to do this graph in purple and then this one in green. I'm not going to make those X's though. So green and purple. Okay, so the first one, purple. Y-intercept, we graph that first. So that's just the point on the y-axis. That's -1. Then our slope is -1 over 2. So down 1 over 2. Rise over run. Down 1 over 2. Okay, so here's our pattern. We're going to eventually connect these dots with a line. And I prefer 3 points if possible. And then we're going to draw our line. So if you don't have 3, you could always go backwards with the same pattern. So over 2, 2 and 1. It's like steps. Okay, same pattern, both directions. Okay, so the green one. So we start off at -4. That's our y-intercept. And then we go up 1 because it's positive this time. So up 1 over... So up 1 over 1, 2, 3, 4. Okay, up 1 over... So the pattern would be like that, but we're running out of graph. So I think we can already see where these two lines are going to cross even before we drew our lines. Okay, so the point of intersection is right here. Let's label it. That is x first. So x is 4, comma, -3. All right, so let's see if we answered everything. It says, graph each linear equation, determine the solution. Okay, one point of intersection is one solution, which is what we found. No point of intersection is no solution. Okay, so let's think about what that would look like. So if we have a graph and we have 2 lines and they're parallel, this is no solution. No solution. And if it turns out that the graphs, the lines that we draw one, then we draw the next one, and it's exactly the same, this is infinite solutions. Okay. I can already tell you just by looking at the equations that there are no examples of infinite solutions, but there will be one that is no solution. All right, I'm going to let you finish that. Again, you can check this in Desmos too. You just pull it up, type in those 2 equations exactly, and then make sure that your graph looks like the one on Desmos. Okay, our final piece. We have exponents this time. Okay, so I'm just going to rewrite this. So 2x to the 4th, 2x to the 4th, y to the -4th, z to the -3rd, all over 3x to the 2nd, y to the -3rd, and z to the 4th. Okay, so we're just going to simplify. That's all we're doing. We're not solving, we're just simplifying. All right, I like to break this up into its parts, and those parts are the bases that are the same. So here's x as a base. These are exponents, so we have bases and exponents. Okay, and then we're just going to take each piece separately. So 2 over 3, if we can simplify that, then we would, but it is that. So 2 over 3. And then we have our bases. So we have x, we have y, we have z. So when we're dividing powers, okay, we're dividing powers, divide powers. What do we do with the exponents? We subtract exponents. Okay, so that's our rule. We learned this already, but that's our rule if we forgot. So we're subtracting exponents. So look at the exponents for x. We have on the top 4, on the bottom 2. 4 minus 2 is 2. For the y, we have negatives. I want to write this one out. -4 minus -3. Okay, put parentheses. Think about it. Don't just try to do it in your head. So -4 minus -3. -4 minus a negative number turns that into a plus. Negative 4 plus 3, use a calculator if you need to. That's going to be negative 1. We have more negatives. So think about 1, 2, 3, 4 negatives. 1, 2, 3 positives. That one becomes 0. That becomes 0. That becomes 0. What do we have left? We have 1 negative left. Okay. Z, we have negative 3 minus 4. Okay, so we have 3 negatives and 4 more negatives, so we have negative 7. Okay, so when we simplify, we do not want negative exponents. So remember our rule for changing exponents to a positive. So if we have this, we could put a 1 under it, and then we just flip it over to get 1 over y, and then now the exponent is positive. Okay, so that's what I'm going to do. I'm going to make this into a fraction, just like we started out, and I'm going to bring this down and bring this down to make those exponents positive. So I'm going to rewrite this whole thing. So on the top, we have 2x squared. On the bottom, 3y to the 1 and z to the 7th. Okay, again, it seems like a lot of work, but all we're doing, we're just simplifying this expression. We're not solving anything, we're just simplifying. And then later on, next year, you will have something like, evaluate if, y equals 2, or sorry, x equals 2, y equals 6, z equals 3. Okay, so then you can substitute those numbers in and then find an actual number answer. But this is just simplifying. So this one here, write another problem and solve. So you can make up your own. I don't know, 6x to the third, y to the fourth, divided by 3x, y. Okay, so this one, you don't have to use this. You could if you want. If there's no exponent, remember, put a 1. So that when you're subtracting, you don't forget that there is a 1 down there. Okay, so you could use that problem I just gave you or write your own. And that's it for day 4.